Alright, this is a quick introduction to the chain rule since I was gone today. I still want y'all to have an idea of what I'm talking about when I come in tomorrow. Okay, the chain rule, and as far as technical terms, says that d dx of f of g of x, so this is a composite function like we did last year in pre-cal, is going to be equal to the derivative of f of gx times the derivative of g of x. Now you can also translate this in different terms. You have to take the derivative of the outside and then multiply it times the derivative of the inside. I know that doesn't make much sense right now, but hopefully after the examples you'll be able to tell what I mean. So the first example is really simple. It's just d dx of x squared to the third power. Now we could multiply this and make it x to the sixth power, and that would make it really simple, but just go with me on this. So take the derivative of the outside first, so move the 3 exponents out in front, leave the inside there, and then I drop the 3 exponent by 1. Then I multiply by the 2x on the outside. Okay, and this is just cleaning it up, and there's my answer. 6 times x to the 5th power. Alright, a couple of technical details. Notice that this 3 came from right here. Sorry for the coughing. And this 2 is because I used the power rule on the exponent on the outside of the parentheses. This is what I meant by taking the derivative of the outside first. Notice that the x squared from the inside is still the exact same thing, so no big deal there. And then I have times 2x at the end. This is the extent of the actual calculus. The second 2 lines, or the last 2 lines, are just the algebra of putting it back together. Now, if we had converted this originally to x to the 6th power, then the derivative of this would have ended up 6 times x to the 5th power, which is the same thing that we got using the chain rule. I just wanted to show you this so you know it definitely does work. Alright, example number 2. This is actually a polynomial. So d dx of x squared plus 3x, all of that to the 4th power. Now multiplying this out would be a serious pain, so we're definitely not going to do that. This is the type of problem where the chain rule really comes in handy. So I'm still using the power rule on the parentheses themselves, so moving the 4 out front, keeping the inside of the parentheses the same, dropping the exponent by 1, and then times the derivative of the inside of the parentheses. Notice I have to put the derivative that I'm multiplying in parentheses also, just to make sure everything works out right. Multiplying the 4 into these last parentheses, that's where I get this 8x plus 12. And then, of course, my original derivative part is still there. Okay. That's all I'm going to show you in this video. We'll work more examples in class. Go back and rewatch the video as many times as you need. Please make sure that you have an idea of what the chain rule does before we get into class tomorrow. Remember that there is still a test on Friday. And chain rule, have not decided, may or may not be a part of it. Probably only one question. But anyways, there you go. Talk to you later.